I'm not an engineer. I'm a college student with a major ADHD problem. Doesn't mean I couldn't be an engineer. I just don't know yet. I digress. My ADHD has taken me down the rabbit hole of 3D printers and computer-aided design, but this didn't exactly come out of nowhere. I bought the Ender 7 right when it came out in September of 2019. The prints came out great, but let's face it, the stock Z-axis setup, it just sucks, so I'm not going to give any more exposition than that, but if you haven't already, watch my first video. It just gives an overview of what my plans are with this printer. After deciding not to purchase overpriced prints and parts, it was time to design the Z-axis that I dreamed of, or at least something that works. First thing was first, this meant that I had to find a model of the printer, precisely design my parts around it, and hope my printer can then print the 3D parts while crossing my fingers that the prints don't fail. All three of which didn't go well. Let me explain. Before I opened up any modeling software, I wanted to see if somebody or Creality themselves had already pre-modeled the Ender 7 so I could just download it and design off of that. Ultimately, the closest thing that I came to was an Ender 7 model download link, but it was buried in the sketchiest looking form that's apparently Creality's. I don't know. I still tried downloading it, but I got stuck behind a register wall and they never sent me the email confirmation, so dead end. Now, since I had to model everything myself, this led to the inevitable, opening up any modeling software. Okay, well, not just any modeling software. My choices were limited, Blender, or FreeCAD. Now, I've had lots of experience with Blender, and while it's great for making pretty things, it's terrible at designing mechanical parts. I mean, you can do it, but there will be pain. So I chose FreeCAD because it's okay at designing mechanical parts. Now, I'm sure you are probably questioning why I didn't just use Onshape or Fusion 360. Well, I don't like not owning my own projects, so no to Onshape unless they want to give me a sponsorship. Anyways, I looked into Fusion 360 and saw the price and walked out the shop. They almost got me with the free for students deal, but I said hell no, there's probably fine text saying that they're gonna steal my soul or something, so. Learning FreeCAD, first of all, is terrible. Most of the tutorials online feel super slow. However, I did find a couple of diamonds in the rough that truly did help. Links will be in the description, hopefully. The game changer for me was ditching nearly every other workbench in the software for just the part design and the SketchUp workbench. Learning how to properly sketch stuff in the software really eased the workflow, and I fell right into it. Fairly quickly, what I once thought was a terrible interface became a playground that I felt comfortable navigating and jumping around. I even started looking into additional add-ons that were uploaded by devoted FreeCAD users. And ooh, a fastener add-on, fancy. The design. My first models for this upgrade project were of the printer itself, and they're awful, but functional. Without the sketch bench, modeling can get extremely disorganized and confusing. But the upside of not using the sketcher is that the primitives and booleans workflow felt a little more intuitive, which helped a beginner like me. Anyway, after I measured all the printer's parts and placement of them thrice over, I sliced away at the primitives until I was left with this rudimentary model of my Ender 7 3D printer. Maybe a little rough around the edges, but again, it was functional. Mind you, I had figured out the parts I needed and the ones that I couldn't print before figuring out where to purchase them. However, I spent a great amount of time trying to find the specific dimensions of the parts that I had to order. My idea was that I'd have most of the 3D prints done by the time they arrived. That idea kind of worked. I was able to model out the parts connecting the bed to the hardware and where the hardware would be placed so as not to conflict with any parts of the printer. Once I had the parts, I pulled out the calipers and measured every nanometer of every piece I had, and then modeled those two. The hardware I eventually ordered was relatively cheap, only costing me about $1 big buck. That's 100 doll hairs of those Monopoly colored papers, you know? This bill of materials included 2 kits from Amazon and miscellaneous stuff too. Look, I tried hitting up the local warehouse for these parts, but when I said I needed a T8 lead screw rod thingamabob, the guy on the phone said, "You ain't gonna have any luck finding that kind of threaded part around here." Then he proceeded to tell me that he didn't have any of the other parts I was looking for either. Back to the bill of mats. First, the kit from Amazon came with a T8 lead screw, 2 linear rods, an aluminum block with a hole, and linear rod bearings. Also some other stuff that I didn't need. I got 2 of those kits, meaning 2 lead screws and 4 linear rods, plus the other stuff total. Second, a pack of 6mm width 20-tooth pulleys with an 8mm bore to fit the lead screws. It came with closed loop belts that I was hoping to use, which I did. Of course it failed because I was trying to super glue them together, which led to the third thing, a 1000mm length GT2 6mm width belt. I only was able to find a 2-pack of this, so I guess I have an extra. And finally, a bunch of metric bolts, nuts, and T-nuts to seal the deal. Now, with all the hardware purchased and the printer measured thrice, parts designed, it was time to print. And oh boy, did it not print. I had to re-level the bed so many times. So annoying. Didn't help that at one point, I took the whole bed apart to scan the mount with the lame paper printer that I have. Yeah, 2D printer. Gross. But yeah, I scanned it, and it came out great. So, after leveling the bed, I had to deal with the ancient PLA that I've refused to toss because 1 out of 5 prints with this moist plastic comes out perfect, at least when overlooking the problems caused by the printer itself. Probably the PLA. But complaining aside, once I decided to ignore the first layer of each print, they magically formed somehow on that layer. You can see just how warped some of the first layers got with these prints, and also how they turned out just fine. With all the prints done, it was time to assemble. Warning, due to my lack of good film equipment, and more so, my lack of a wallet to get said equipment, and even more so, due to a lack of my discipline, I failed to film most of the assemblage. Sorry to the viewers. Filming laziness aside, check out how awesome the first assemble came out. At this point, I was really happy. I figured that even if some stuff didn't align, I had a great starting point to fix it and go from there. And right I was. Getting all the rods to fit was rather easy. I tightened most of the bolts and T-nuts down to be tight enough that they'd stay in place if left alone, but able to slide around if I needed them to. The screws that set the rods into place were left loose so that the rods themselves can slide within the bearings, and I slid the mounts around until they were able to slide freely. Once they were, I set the rods into place with the screws after putting the appropriate hardware on them, like the aluminum block and the linear bearings. Rods in place, I attached the printed bed mounts to the rod bearings and T8 blocks. They fit rather perfectly, but I quickly found out that the screw holes at the end of the bed mounts were off by only a millimeter. As quickly as I found this out, is as quickly as I should have accepted. I was off with my dimensions. I did not want to accept that because my immediate thought was that I would have to completely redo my whole CAD model of the Ender 7. So I redid the entire CAD model of my Ender 7, and it turned out exactly the same. Because honestly, I didn't actually remeasure much until it was absolutely necessary to. Also, mainly because I'm not done with the printer model. Extra full-time college student schedule problems, you know? Anyway, even when it was deemed necessary to remeasure, I just bored out the holes a bit more to account for my error and called it a day. After checking if everything was going to work, I tightened everything down and into place and turned the printer on. And as you can guess from the lack of inserted film here, it didn't go too well. On the left side, the aluminum block was scraping the extrusion when it moved up or down. Now, I knew this would be a problem as I initially noticed the minor collision in the CAD, and I did account for this plenty on the right side by taking my Dremel and milling bit to the block to get it down to size. However, for the left one, I only filed it down a little bit, but that's where I'm at today. I know this upgrade is going to work out perfectly for my needs. It just needs a bit of revisioning to get it just right. I need to address the V-rollers still, but that's a dragonous monster of a problem. Not really, I guess, but still. Also, the belt barely reaches the tensioner, and the current tensioner design is colliding with the connector doodad for the main lead screw. I digress. I'll get to that in my next video. For now, I'm super happy with how this is turning out. I've worked extremely hard to get where I am to help myself and other fellow Ender 7 owners in this situation. So let me know if you're interested in getting my design when it's done. With that said, subscribe, noti bell, comment any suggestions for the Ender 7. Ace out.